All right, let's start the chapter 2 in part 2. Um, Earlier we just studied linear equations, now we will move on to algebraic expressions and entities. Now, we will go with some definitions. Expressions are formed from variables and constants. So, now in this algebraic expressions, we need to know what is expression. It means it is just a mix of variables and constants. So this is just an example of an expression. When it comes to equation, there will be expression in left side, one expression in right side. It's just one part of that. So this is example of expression. Here it's saying there are two terms, 3x plus 9. The term 1 is 3x. Term 2 is 9. Term 1, it has two factors. One is 3, one is x. So the numerical factor is called a coefficient. So 3 is called coefficient and x is a variable. But in the next term is just 9 in numerical. So it's just a constant. Now we will know some of the terms in algebraic expressions and entities. So the terms like monomial, binomial, trinomial, polynomial. So we will know what are those. It's better to know these things because as we are getting exposed to algebraic expressions, we should know all these terms. We will try. We will just be exposed in this 8th standard to limited content, but these are going to be helpful a lot in ninth and 10th standard. So a monomial expression is just monomial means one term. Okay, that means here in just example it is giving 3xy. So it's called monomial. It's just one term. Next one, binomial. What is a binomial one? Having two terms. Here is term one and term two. That is binomial. Trinomial means three terms. Okay. Polynomial means more than one. Is called polynomial. Is saying just what is a polynomial? One or more terms with variables with no negative integers as exponents. So per se, this is 2x plus 3y. So it shouldn't be saying that 2x to the power minus 1 or minus 2 like that. No, that is not polynomial. So it got to be positive exponents. That's what it is mean. Now, while solving these algebraic expressions, equations, and factorization, whatever you say, the chapters we need to remember some identities that is going to help us to solve these equations and expressions and reduce them from a larger expression to a smaller expression or use factorization to concise it or solve it. So we will be exposed to few identities here and we need to remember these identities in order to solve that. So let's just see what are those. An identity is a equality which is true for all values of the variable in that equality. Now let's see one example. So this is a identity. So we'll say a plus b whole square equal to this. So this is true for all of it. So if you try to multiply it, it is going to expand to like this. Like if you do a plus b multiplied by a plus b, because it's raising to a square, it will come out to be b. So if you remember this, it would be easier for you to solve a algebraic expression. While doing factorization, it would be faster for you to factorize it. So this is basic. So a plus b whole square equal to a square plus 2ab plus b square. A minus b whole square equal to a square minus 2ab plus b square. A plus b multiplied by a minus b equal to a square minus b square. And then x plus a plus x plus b equal to x square plus, um, there is just a typo, I need to change it to x square plus a plus bx plus ab. So if you can remember this, that would be easier. So next one, now we will go with examples. So this is what algebraic um, expressions. We got to know what is different monomial, binomial, and all. What is expression mean? What is a coefficient? What is a variable? What is a constant? And then we need to solve these expressions. So it's saying, okay, these are the expressions. Please add these expressions. This is one kind of stuff. Now consider it just I'm just explaining the steps how we are going to solve it. Consider similar variable groups while adding algebraic expressions. So if you group them in such a way that it would be going to solve, because all are kind of variables, now how will you know these are not numerics? You will solve variables means you will cut one variable, plus variable, minus variable, then that evens out, or factorize something, then so you need to group them together in order to solve it. So I just try to place them. So you see here, it's a funny thing. If you see here, AB minus BC, then it starts with BC minus CA and all. So AB plus AB, and there will be minus AB plus BC. Here it is a minus BC plus CA, and there is a minus CA. All cross each other, and that turns out to be 0. AB is crossed by minus AB, plus BC is crossed by minus BC, and same goes with CA. So this is one addition example. Now we'll go with subtraction. So this is one and another one. We need to subtract it. So same way we need to group it. Um, so terms with similar variables and similar variable groups has to be grouped together in order to subtract it. So A you need to subtract with AB you need to subtract with AB, B you need to subtract with V, then only you can reduce it to a smaller form. So here we, after the subtraction, we got 8a because 12a minus 4a, and then here minus 9ab. Now it minus and a minus plus becomes, so it becomes minus 2ab, plus similarly it becomes 2b, and then so you need to expand this minus and all, and plus becomes minus and minus becomes plus, and then you subtract the similar variable groups, and then you come out to be this expression. Simple, as we do normal addition and subtraction. In that case, we have numericals, we know how to subtract. Here, just variables, so we need to group them into right variable groups. Multiply these binomials. So we will do one example for multiplication also. We did addition and subtraction. So here we need to multiply it. So just expand and multiply it, and then we will get to know that how we are going to do that. So it's just term by term, two terms multiplied by two terms became four term. That's how is the multiplication can do. If would have having similar variable groups, we could have minimized it, but that's not the case. So this stays as it is because all these are different variable groups. Simplify this expression. Here it is also um, a multiplication, but we will use some identity rules. So this say if you will group it, a plus b is one group and c is another group. So you will see a plus b group plus c, a plus b group minus c, and that can be deduced to a identity a plus b whole square minus c square. And then when you do that simplification, you can put it a plus b whole square equal to this identity minus c square. So this is a multiplication entity was there with groups of 3 total 6 maybe in length. Now it reduced to 4 um, terms. Here another example where we need to use the four identities equations that we discussed to solve this. So this is one where we need to solve this. Here it becomes b square plus a square, then b square minus a square, and then we can use the simple identity here to make it b fourth minus a fourth. So what I was referring to is, to solve this we need to remember these identities, then only we can solve these things quickly. So we just used this one, and we use this one already, and hence on, if you by heart these, then only you can solve this. This is another solve we need to do. Here we need to simplify, both are having Hammond, so square plus square. So we just expanded the left one and the right one, I mean the first one and the second one, and it came out to be, then we need to group them with the similar variable groups. M square has to be grouped with M square, N square has to be grouped with N square, and then so that it would be easier for us to add them. So it has four groups. Now it reduced to 3 1, 40 on n square plus 41 n square plus 80 mn. That's how we solve and simplify it. Next topic, next chapter would be factorization. So the key to these things is we need to go and the chapters in the book. Chapter 2 is linear equations. You need to practice all the exercises there. And then algebraic expression and identities is chapter 9. All the exercises you need to practice there. Only if you practice, then only you can able to remember and get more idea about it. If this book is kind of less for you to practice, you can have supplementary books like R.S. Agrawal or whatsoever you can find online, or there are guides also available to practice more. Thank you guys. We will meet in the next chapter.